So now we are starting with circular measure, and I'll be needing some people from the audience that they have the calculators ready. So now this is very much of a calculator based thing. There are questions which are not so calculator based, but usually it's related to calculator. So now this question, yeah, even before that, let me write down the formulas that are needed for circular measure. First thing first, radians, calculator in radian mode, and angle in radians. Both things are necessary. The second thing, S is equals to r theta. Theta is in radians. Area is half r square theta. Again, theta is in radians. What is S? S is the arc length. What is A? A is area of sector. Naturally, you would be using sine, cosine, tangent, sine rule, and cosine rule. An area of triangle, that is half AB sine C, or area of triangle half base into height. So all this knowledge will be used. So let's get started. This first question, it says the diagram shows a circle with radius r. So that is the radius r. OP is r, OQ is r. Let me highlight it. Very comfortably, we will solve each question. So this is OP and this is OQ. They are the same because they are the radii. The line PT is tangent to the circle. So this is the whole tangent of which a small line segment is PT. This angle is alpha. The line OT meets the circle at Q. So OT meets the circle at Q. So let me just add this portion separately. And that is the whole thing. That is OT. Express the perimeter of the shaded region in terms of R and alpha. First thing first. So if I talk about this, perimeter of shaded region, PQT. So what does that include? That includes this thing, which is PQ. That includes QT, and that includes PT. So first of all, perimeter of shaded, that is arc PQ plus length PT plus length QT. Arc PQ is the purple one. So that is this thing. QT is the green one. PT is the blue one. So let me erase the excess thing. So let me just erase this. Let me just erase this. So that is this blue one. That is PT. Now the strategy is very important. Do not rush into things. Write everything out. Make sure your calculator is in the radian mode. Make sure the angle is in radians. Well, the first question is in terms of R and alpha. So that's not that big of an issue. So that is good. So now the first thing is arc PQ. Let me talk about the purple thing. So when we talk about arc PQ, therefore arc length PQ is equals to R alpha. The next thing, that is PT. How can I evaluate PT? So in order to get PT, I know that this is a right angle triangle, and with respect to alpha, this is the opposite. So therefore it's associated with this is opposite and this is adjacent. So it's not sine, it's tangent. Tangent of alpha, that is equals to PT divided by OP. Tangent of alpha is PT divided by R. Therefore, PT is R tangent of alpha. Next thing, I'm interested in QT, but I cannot separate it out. I have to find the whole thing first. So either it's based upon Pythagoras theorem, or easier, let's just use sine, cos, tan, whichever one is applicable. So I have R, this is the hypotenuse, this is the adjacent with respect to alpha. So let me use cosine. So first of all, if I talk about this line, which is I need to find QT. So that is green color. So I need to find QT, and there is also this red color. So this is OQ, this is QT. So OQ plus QT is OT. So I'll first find OT first. Cosine of alpha, that is OP over OT. Cosine of alpha is OP, which is R divided by OT. Therefore, OT is R over cosine alpha. But OT is OQ plus QT. But OT is OQ plus QT. So this is also R. So OQ is R. OT is R over cosine alpha, and this is QT. We are interested in QT. So QT is R over cosine alpha minus R. So this is QT that we found. So let me highlight this. So this is QT. PT is the blue one. And let me also highlight this. That is R cosine alpha R. And the purple one, that is arc length. So I'll be needing to copy this thing, not this thing, on the next page for the next part. It's not over yet, just hold for a second. And then what do I need? I need the perimeter, so I need to add all these three. So therefore, perimeter is R alpha plus R tangent alpha plus R over cosine alpha minus R. So therefore these two are, no, nothing is cancelling out. So therefore this is coming out to be, let's take R common. That is alpha plus tangent alpha plus 1 over cosine alpha minus 1. So let's double check the first part. So this is part 1, the working is for part 1, and the answer should be over here. Now they have done using Pythagoras, that's or we did this thing. And sum of the three parts including R alpha. So this is R tan alpha, this is R over cosine alpha minus R, this is R alpha. So they did not bother writing it down. So P is basically PT plus QT plus the arc length. What's the name of the arc length? Arc length is PQ. So it's exactly the same thing. Okay, all good. Now the next part. Now we are focusing on this part, which is part 2. Now they are giving us value. They are saying in the case where R is, when alpha is pi by 3 and R is 10, find the area of the shaded region correct to two significant figures. That means work in 3 as if. So I'll just do the steps. You can double check the working on your end, and then I'll show you the mark scheme. So now first of all, what do I need to do? So I have this thing, which is R. If I want to calculate PT, the whole thing, I can. And this angle is over here, that is known, which is how much? Which is this thing, which is pi by 3. So if I say tangent of alpha is PT over R, PT over OP. Tangent of pi by 3 is PT, that's unknown, and R is 10. So 10 is being used, pi by 3 is being used. This is centimeters. They did not even say centimeters, that's 10. So root 3 is PT over 10. Just look at my working. PT is 10 root 3. That is the answer for the blue part. So this blue part, that is the answer. That thing is done. Now this is step 1. I need to find the area of the triangle. Second part, area of triangle. Which triangle is this? OPT. OPT, that is half base into height, half into R into height, which is 10 root 3. So 100 divided by 2 is 50. That is 50 root 3 units square. That is the area of the triangle. This is base, this is height, and I got this area. Now I need to find the area of the sector. So now let me draw a line over here. Let me just reduce it. Let me adjust few things. Okay. Now it looks neater and cleaner. Now I can say area of sector. Also make sure to write the name OPQ. So that is OPQ. That is half R square theta. That is half into 10 square into theta. Theta is pi by 3. 50 pi by 3 units square. Therefore, area of shaded region, that is area of triangle minus area of sector, that is 50 root 3 minus 50 pi over 3. Take 50 common out, root 3 minus pi over 3. If the answer was in the exact form, I would leave the answer as it is. This is exact form answer. But since they are asking in decimals, this is 50, this is 1.732, this is 3.142 divided by 3, and then you would use a calculator, and this is the answer that you would get. This is exact. This is 52.36. They're asking correct too. 3SF, work in 3SF, final answer 2SF. So I think this answer is this is 86.6, this is 52.36. The difference is the answer. So therefore, I'm not writing it over here. It's already written over here. That is 34, correct to 2SF. So work, first write the answer in 3SF. Then write the answer into SF in this particular question. This is what is required. All good, all clear, straightforward. Now look at this question. Now let me pause the recording. Let me wait for you people to try this out. So now let's look at this question. इस question में ये कह रहे in the diagram AB is equals to AC is equals to 8. AB, AC, ये दोनों 8 के बराबर है. So let me just draw the line. This is AB, this is AC, that is 8. And CAB is 2 over 7 radians. The circular arc has center A. So this is the circular arc. It has a center A. And this is the angle that's right over here. The circular arc CD, there is another circular arc, that is CD, has center B. So now this is BD, this is BC, and the circular arc is because of this that goes like this. Let me just go backtrack. Okay. Now it says ABD is a straight line. ABD is a straight line. Show that angle CBD. CBD is 9 over 4 pi. 9 over 14 pi. First thing first, let me label this as theta. Let me label this as theta. These two sides are equal. Therefore, this is an isosceles triangle. So part 1, ABC. Triangle ABC is isosceles. And theta plus 2 over 7 pi. This equals 2 pi. Pi is 180 degrees. 180 degrees is written as pi radians. 2 theta is pi minus 2 over 7 pi. This is pi common, 1 minus 2 over 7. This is 2 theta. 2 theta is pi, 7 minus 2 is 5, 5 over 7. Make theta the subject, that is pi over 2, 5 over 7. And this is 2 over 7 and this is 5 over 7. And therefore this is 5 pi over 14. This is theta. But I'm not interested in theta. I'm interested in this angle, which is right over here. This is beta. So beta plus theta equals 2 pi. Therefore beta is pi minus theta. This is pi minus 5 pi over 14, which is 14 pi minus 5 pi over 14, which is 9 pi over 14. And that is the answer that's written right over here. Show that the angle is this much. Now, someone can also say another approach, alternative approach. The exterior angle of a triangle is equal to sum of interior opposite angles. Beta is theta plus theta. Exterior angle of a triangle is equal to sum of interior opposite angles. So therefore, we know that theta is 5 pi over 14. So I can simply add these two. So let me just double check my working. Theta plus 2 pi over 7. Theta plus 2 pi over 7 is this. I first found the value of theta. 7 minus 2 is 5. That is 5 over 7. This thing. That comes out to be 5 over 14. 5 pi over 14. That is theta. And beta plus theta is pi. Beta plus theta is pi. So therefore, I found this value of beta. Now, over here, what else is there? So this is this plus this, not this theta. Let me correct myself. That is interior opposite angles. So let me just erase this angle. This one is erased. Just waiting for the stroke eraser. This and this. So basically, it's this one and this one. So this is this plus 2 over 7 pi. This is 5 pi over 14 plus 2 over 7 pi. This adds up to the same thing, which is 9 pi over 14. You can double check the answer. So this one is all good, all clear. Okay. Let's move on. Now it says find the perimeter of the shaded region. Now, how do we find the perimeter? Again, the approach. Perimeter of shaded is basically BD plus BC, and no, not BC, actually it's this one. BC arc length, arc BC, and DC. That's also an arc. So let's first calculate BC. This is for 5 mark. So first of all, if I want to calculate BC and have they given the answer in decimals, yes, it will be in decimals. So this is question number 5. I hope this is the right thing. This is answer for something else. 2017 February paper 1-2. Question 4. I think this is something else is pasted. So first of all, let's use cosine rule, and I can say, or sine rule maybe. So 8 and 2 pi and this thing. BC, I first need arc length BC. So arc length BC, that is r theta, which is 8 into 2 pi over 7. That is 16 pi over 7, and this is in centimeters. That's the first thing. That is BC. That is this one, the blue thing. So let me just highlight this thing. That is arc length BC. That's right over here. Let me erase everything else. So this blue thing is the one that we found. What else is there? I'm interested in finding BD. Now the next thing is BD. Isn't BD the same thing as CB? Yes, it will be the same. Because if it's not the same, how can this arc be formed? So these two are exactly the same length. These two are the same length. So let's evaluate BC. So cosine rule or maybe sine rule. This angle was theta. Theta is 5 pi over 14. This angle is also the same. So we are looking for the length. BC divided by sine of 2 pi over 7. That is equals to 8 divided by sine of 5 pi over 14. Naturally, you should be using your calculator. BC is 8 and this is sine 2 pi over 7 and this is sine 5 pi over 14. You will be needing a calculator and you'll find the value of BC, and BC is the purple color thing. So that is BC, what you get over here, and whatever the answer is, that is the same thing as DB. So this is DB, so this thing is found. So this is step 1. That is finding arc BC. The second one is BD. BD is the same thing as BC. This is step 2. BC is the same thing as BD. And what is left now? The last thing, that is this, let me color it green. That last thing is this. Let me make it thicker. So now in order to find DC, so now we are finding arc length DC. DB is the radius and this angle was beta. Beta is what we found, that is CBD, 9 over 14 pi. 9 over 14 pi, and radius is BC, whatever this value is. This value right over here, that is the radius. So therefore arc length DC is this radius that you have found, the one in purple, and let's multiply it with 9 over 14 pi, and then perimeter is sum of all these things. So step 1, step 2, step 3, add them all, that is the perimeter. Is this all good, all clear? I did not use a calculator, I left it for you, I just showed you every single step. Okay, now let's look at this question. I would like you to try it out. Let me pause the recording. So now let's look at this question. The diagram shows two circles with center A and B. Center A, center B, having radii 8 and 10 respectively. The one with center A, this has a radius of 8 and this is the circle. The second one has a radius of 10, a diameter of 20, and this is the circle. It goes like this. So now it says find angle ABC. No, I missed this part. The two circles intersect at C and D. So it's intersecting at C, it's intersecting at D. Where CAD is a straight line. CAD is a straight line. And AB is perpendicular to CD. AB is perpendicular to CD. Find angle ABC in radians for 1 mark. Find the area of the shaded region for 6 marks. Now, first of all, if you want to find the angle ABC in radians, so that is simple. And let me just make it thicker. So this is, first of all, this goes like this. This goes like this, 10. And this one is this thing. So now, if I need ABC, just this much, let me label this as theta. So part 1, let me denote angle ABC as theta. ABC, that's perfect. Therefore, sine of theta is equals to 8 over 10. Theta comes out to be, I think, 0.927, something like that. There it is. 0.9273, 0.9273 radians. Work in 4 significant figures. Final answer 0.927 radian 3 SF. Now the next part, find the area of the shaded region. Now if you want to find the area of the shaded region, what do you need? Let me draw another line. So let me choose the green marker again. And this goes like this. And this B is forming this sector. So this sector that's right over here, the one in purple, actually let me draw it in green. So this thing in green, that is because of this sector. So basically, this is BC, this is BD, this angle is 2 theta, and this is the sector being formed. This is the arc length, the whole thing is a sector. If I find the area of the triangle and subtract it from the area of the sector, I'll get this region. So let me label this region in purple. That is this one right over here. So I'll simply write down the steps. The first step, that is focus on sector, which is CBD. CBD. Angle of the sector is 2 theta. That is 2 into 0.9273, whatever that comes out to be. Radius is 10 centimeter. Find area of sector CBD. That is half r square theta. That is 2 into 0.9273. Area of triangle. What's the name of the triangle? CBD. That's half base into height. This thing is 6 centimeter due to Pythagoras theorem. And this again is 8 more. So half into 6 into 8. Area of triangle. That is half into 6 into 8. 48. This is 24 centimeters square. And is it in centimeters? Yes, it's in centimeters. Something centimeter square. Therefore, area of this purple region, that is the difference between the two. So this is AB is Pythagoras, BCD is 48, BCD. That is half into 6 into 8 plus 8 is 16. I made a mistake. Let me correct myself. That is 8 plus 8. That's not simply 8, that's 8 plus 8. So therefore, this is 48 centimeter square. That's my mistake. And from it, I subtract the triangle. From the sector, I subtract the triangle. So how much is that? Let me multiply it out. So this is 0.9273 into 50. That comes out to be 46.365. This is 46.365. The difference minus 48, this comes out to be negative, actually positive 1.635 centimeter square. That is the area of the shaded region. Okay. And half into 10 square, that is 100, that is 2. Again, I made a mistake, my bad. This 2 and this 2 will cancel out. This 2 and this 2 will cancel out. This is 100 into this. That is 92.73 centimeter square. Therefore, this is 92.73 minus 48. This comes out to be 44.73 centimeter square. That is this. That is right over here, which is red in purple. Now, the third step, that is the semicircle, center A. Semicircle, center A, radius 8 centimeter, area of semi, that is half into pi r square. That is half into pi into 64. That is 32 into 3.142. That comes out to be 100.544 centimeter square. Therefore, the last thing, area of shaded region. So in green, area of shaded. That is this whole semicircle minus the segment. So that is 100.544 minus 44.73. And after rounding off, what do we get? We get 55.8 or 56.0. Let me round off. Minus 44.100.544 minus 44.73. That comes out to be 55.814. I'll round it off and I'll write it as 55.8 centimeter square, correct to 3SF. So that is the working for this one, 55.8, 3SF. I don't know why they are giving 56.0. Maybe some premature rounding off, which they should not mark as correct. Try out this particular question. So now let's look at this question. The question says, the diagram shows a semicircle with center O. Center O, semicircle. This is 6, this is 6, this is 6. The radius OC is perpendicular to the diameter AB. OC is perpendicular to diameter AB. The point D lies on AB. Point D lies on AB. DC is an arc of a circle with center B. DC is an arc of a circle with center B. Calculate the length of the arc DC. Find the value of area of region P, area of region Q. Give your answer correct to 3 significant figures. Now let me do the first thing. Give your answer in exact form. I'll work on that, and then in the end I'll use a calculator. That is the first and foremost thing. So now let me write a point, that is work in exact form till the very last step if possible. So in this scenario, yes, it's possible. So we will work till the very last step. Now, first of all, Uh, Let me just join few lines. So let me draw DC like this, and let me join D till B and C till B. That is the first thing. Okay, so now let me join it like this. Why is not turning into a straight line? That is a straight line. Okay, now it looks perfect. Now second thing, if this thing is 6 centimeter, that means this thing is also 6 centimeter. That's the first thing. Which means that this is an isosceles triangle, which means that this angle is 45 degrees, this is 45 degrees, this is pi by 4, this is pi by 4. That's the first thing. So triangle OBC is isosceles triangle. That's the first thing. Second thing, if I use Pythagoras theorem, what I'll do is that I'll say BC square is equals to 6 square plus 6 square, which is 36, which is 36 square root, which is 2 times 36. I can write it like that. And this can be written as 6 root 2 in the rationalized form. 6 root 2, this is BC after the square root. So this is BC, which is 6 root 2. Okay, this is done also. Now I'm focusing length of arc DC, that thing is done. Length of arc DC is coming up. Therefore, length of arc DC is equals to r theta, which is 6 root 2. This is the radius. This is the radius, and theta is pi by 4. So 6 root 2 into pi by 4. So this comes out to be 3 over 2 root 2 into pi. So let's see how they have written the answer. 3 root 2 over 2 pi. This is one option. This is the option in decimals, 6.66 or 6.66 centimeters, correct to 3 significant figures. That's your choice, because they have not specified it. All good, all clear? Now this is for 1 mark, but the working will be used for the other parts also. So don't be depressed, because your effort will be used in the second part. Now what else is there? Now let me highlight this portion, which is the green portion, and let me use a green marker over here. Can I calculate this area? Yes, I can. So therefore, area of green thing, that is area of sector, which is CBD, minus area of triangle OCB. Yes. Area of triangle is half into 6 into 6, 36 over 2, which is 18. Area of sector is half r square theta. This is half, this is r square, which is 6 root 2 whole square, and theta is pi by 4. So basically, this is root 72. I can also write it like this. And root 72 square, that is 72. So I can write it like this. I can write it like 6 square is 36, root 2 square is 2. This is pi, this is 4. Let's slash it off. The 2 and the 2 cancels out. 4 ones are, 4 nines are. So therefore this comes out to be 9 pi minus 18 centimeter square. That is the area of the green region. This thing. This is what I've obtained. That's the first thing. That is basically area of Q. 9 pi minus 18. Now we know that if this is marked as purple, P plus Q, that is a quarter circle. So area of P plus Q is a quarter circle, the radius is 6. So area of P plus Q is area of quarter circle, which is 1/4 of pi into 6 square, 36 over 4, this is 9 pi. This is P plus Q. We need the region, area of region P. So therefore, area of P is 9 pi minus 9 pi minus 18. So 9 pi cancels out. This comes out to be 18 centimeters square. That is perfect. So P is 18, Q is 9 pi minus 18. So area of P is to area of Q, that is 18 divided by 9 pi minus 18. Now use a calculator. This is the answer in the exact form. Or you can use a calculator. There it is, 18 over 9 pi minus 18. And this comes out to be 1.75, correct to 3 significant figures. So that is how this particular question is done. The examiner could be in a mood of asking this question in the exact form again. And what else is there? So now the thing is that it's all about getting used to the formula, thinking out of the box, doing every single question step by step, showing all the working, work in exact form as much as possible. Where it is very, very necessary, then you have to use the calculator, convert it in decimals, make sure to work a level of accuracy more than what is required. So this is the recipe for success in your P1 exam. Till the next class, take care.